Okay, the very last thing that we will do in this chapter is the redox stoic, which is pretty much combining what we did in terms of the redox equation and combining it with solution stoichiometry that we did on chemistry 20. So we have an example here. A sample of 10 milliliters of sodium chloride solution requires 10.8 milliliters of 0.0834 moles per liters of potassium permanganate solution to reach the equivalence point for its oxidation to aqueous solution, aqueous chlorine, in acidic solution. Calculate the concentration of chloride ion in its original solution. So first of all, original solution means that we are dealing with the one that is in the reactant side. But first of all, let's start by writing the redox equation. So when we write the redox equation, we will start listing all the entities. So we have sodium, which is +1, and then we have chlorine in aqueous solution. Chlorine in aqueous solution again is -1 because sodium chloride is a ionic compound. So when it is in water is dissolved. And then we have potassium permanganate. So potassium permanganate again is a ionic solution. When it is in water is dissociated into their ions, and then permanganate NO4, which is 1-, and then solution is water. So water, liquid, those are all aqueous solution, water, and then it's to reach the equivalent point of its oxidation in acidic solution. When we are saying acidic solution, that means that we have proton, which is H+. Okay, so after we state and we identify all the species of the equation or in our solutions, what we do is we identify which one is oxidation agent and which one is the reduction agent. So sodium is an oxidation agent, because you will see it in the table on page 7, as we have mentioned, is on the side of the oxidation. Which is the left side of the reaction, and you will see almost at the end of it when it's Na plus aqueous plus 1 electron will give you Na solid, and then chlorine is reducing agent, which is because you see it is on the right side of the equation, so it is a reducing agent. And then we move to potassium. Potassium again is an OA, oxidation agent. And then we notice something, that permanganate included with hydrogen, so those two together are oxidation agent, and water is an oxidation agent and a reducing agent. Okay, So the next step will be to identify which one is the strongest reducing agent and which one is the strongest oxidation agent. When we are identifying the strongest oxidation agent, we'll see which one is at the top of the left side. And as you notice, permanganate and hydrogen are at the top, so this becomes the strongest oxidation agent. And then when we take a look at the chloride and water, then we notice that chloride is at the bottom, which means that is the strongest reducing agent. Okay, so now we start with writing half reactions. So we'll have for MnO4 -1 plus the reactions that are in our table. Okay, plus it's saying there 8 hydrogen plus 5 electron will be Mn2 plus in aqua solution plus 4 H2O in liquid. Okay, and then the other one is 2 chlorine. We'll write it from the other side because now we have so we'll go on the other side of the equation. 2 Cl minus will be Cl2 plus 2 electrons. However, since number of electrons in those two half reactions are different, we will find the common multiple for it, which is 10. So what do we have to do? 5 to make it 10, we have to multiply everything by 2. And what do we have to 2 to make it 10, we have to multiply everything by 5. And so in this way, the electrons will cancel out. Okay, so now the electrons will cancel out because we have 10 electrons on the first half reaction, 10 electrons on the second half reaction, and then the final redox equation, net redox equation will be 2 permanganate in aqua solution plus 2 times 8 is 16 hydrogen. Okay, there is nothing else here, but we have 2 times 5 is 10 chloride, and they are all in aqua solution. Then on the reactant part, we will have 2 permanganate, 2 magnesium, 2 plus 5 chlorine and 4 times 2, 8 water. Okay. What do we have to keep in mind? Because what they are asking for in our question is to calculate the concentration of chloride ion. So when we write chloride ion are found only in potassium chloride. So no, they are asking for chloride ion. Sorry, they are asking for chloride ion. So then what we will do is we will sort what is given here. So we have 10 milliliters of sodium chloride. Okay, sodium chloride. So now let's sort out what do we have here. So what is given here is that we have 10 milliliters of sodium chloride. Okay, so sodium chloride is 10 milliliters in aqueous solution. I'll write it with a different color so we can see. 10 milliliters of sodium chloride. So now when we have 10 milliliters of sodium chloride, it's the same as saying that we have even 10 milliliters of chloride ions, because they are dissociated into the water, and then they are forming the same volume, into the same volume. Now let's move on. What else is given here is given that we have 10.8 milliliters of potassium permanganate. So when we write the formula for potassium permanganate, what we have is, let's see, what do we have? The formula for is K, it's KMnO4. Okay, so this is an ionic compound, which is when it is dissociated into ions is potassium plus permanganate minus. So again, the number of the volume of permanganate is the same as the volume of the potassium permanganate. Okay, so this was 10.8 milliliters as well, and then the concentration is 0.0834 moles per liter, and it is 1-to-1 ratio, so it is the same thing. This is a volume, and the concentration is 0.0834 moles per liter. And we are looking for the concentration of chloride ion. Okay, so we'll start now with, and always when we start in Stoic, we start with what is given. So let's deal with the permanganate because we have everything given here. So will be 10.8 milliliters of permanganate, MnO4 minus, let's convert it into liters, so 1,000 liters of permanganate into 1,000 milliliters into 1 liter of permanganate, O4. So milliliters and milliliters is canceled out. What do we have up to this point is liters of permanganate. And now let's use the concentration. So when we have this value of the concentration, is saying that we have in 1 liter of the solution, we have 0.0834 moles of permanganate. So then we'll go to cancel the liters that we have here at the numerator. We will need to have the liters into the denominator. So 1 liter of permanganate has 0.0834 moles of permanganate. So liters and liters are canceled out. And now to move from 1 liter from moles of permanganate to moles of chloride actually ion, we will use the molar ratio. So will be 2 moles of permanganate are requiring 10 moles of chloride. So moles of permanganate and moles of permanganate are cancelled out, and this is into 10 milliliters of volume, or 0.010 liters. So then, up to this point, we would have liters of permanganate. Up to this point, what we would have will be moles of permanganate. Up to this point, we will have moles of chlorine, and dividing it by the volume, we will have moles per liter. So after you enter this in your calculator, you will have a value of, I believe it is the concentration of chloride ion is 0.901 moles per liter. So check your calculator and your calculations, and this is the redox stoichiometry, which is actually no different from what we have done before. What do you have to keep in mind is that you have to write a net redox reaction, and then keep in mind, bring the information that is on the question, even though that it looks like it is not belonging to the ions, but in fact they do, and do stoic. That's it. Okay, for more examples, I will see you in class, and I hope that you will understand those lessons and those concepts, because you will write a quiz after that. See you in class.